All right. Is anyone here? All right. Is anyone here? Let's see. Think. It says there are 4 watching. It says there are 4 watching.
Can I go back in time?
Okay, it's backwards, so I think I can adjust that. Let me adjust my outputs. Sorry, this is a little bit of a new technology. Let's say tools, video editor. Nope, that's not it. I should have. Okay, let's see. Oh, here we go. Layout. Let's try doing that. Is that better? All right, and is audio acceptable? Okay, excellent. So, unless there's a specific problem request, because I think this will ultimately record into a YouTube video I can post on my channel, I'm going to go directly through polar coordinates, because polar coordinates is a heavily tested item, 4 questions out of your 30, and I know it's one of the more difficult sections. So, I'll just start with polar coordinates. However, I can see, one, I can respond to any remind right now on my phone, and I can respond to any chat in the chat for the live video. So what that means is that you request a problem, I will stop doing polar and I'll go to it. But for the meantime, I'm going to work on polar. All right. So deriving our polar to rectangular equations. So these is just something we're going to have to memorize. So these equations are going to be r squared is equal to x squared plus y squared. And then theta is going to be the inverse tangent of y over x. In addition, you have x is going to be equal to r cosine of theta. And y is equal to r sine of theta. Alright, and I have the solutions previously worked out. However, I do believe just by looking at it, it could be beneficial to actually go through the solutions. Alright, so let's see if I can zoom in with the document cam. Alright, that seems good enough. Alright, so this is going to be weird. I don't have perfect live feedback, but maybe I can here. Alright. There we go. Alright, so let's start with the first problem, unless there's a specific request. And we have 4 watching. Alright, so I guess it's just me and you, Dylan, right now. Archaeologists want to create a map of a recent dig using polar coordinates. On the grid, they used a rectangular coordinate system and marked the king's tomb at -12.5. What would be the approximate coordinates of the tomb if marked on the polar grid? Well, let's start off with we're going to convert from Cartesian to polar. And notice this is when x is -12 and y is 5. So when x is a negative number and y is a positive number, this is putting us in quadrant 3. So first of all, we can do r squared is equal to x squared plus y squared. So r squared is going to be, and in fact we can just directly evaluate r as the square root of -12 squared. And that's not the best. Let me reduce the brightness as much as possible. -12 squared plus, back in the square root, plus 5 squared, and that's going to give us a value of 13. So r is equal to 13. So that's immediately going to eliminate answer choices C and D. And then we know we're in quadrant 3. So we're going to find the inverse tangent of y over x. So for the next problem, we find the inverse tangent of y is 5 and x is -12. And so that's going to be -0.39 radians, but we're going to go back to degrees, so make sure we're in the right mode. Degrees. So we find the inverse tangent of alpha y 5 over negative 12. Oh. So that's going to be negative 22.61. So our calculator output here is going to be negative 22.61 degrees. But what we can do is, because we know it's in quadrant 3, you know that's going to be subtracting from 180 right here. So our theta value is going to be equal to 180 minus 22.61. So 180 plus that answer is 157.38, and that's going to be answer choice A. So what we have to do, know our polar to rectangular equations for this one, know what quadrant it is based on the coordinates, and do our conversions. So that's problem 1. Let's go to problem number 2 once again. Please message me on Remind or message me through the Google chat if you want me to do a different problem or you want me to be doing something else. Also, I guess I can check my, if you send me an email to my email address, I can immediately check that as well. But please, we can keep the communication going on your end because I want to be doing what's most helpful to you. This is your time and your exam. All right. Number 2. What are the polar coordinates of the point 2 root 3 negative 2 where 0 is less than theta is less than 2 pi? Well, let's start the problem. R squared is equal to x squared plus y squared. Fair enough. R squared is equal to 2 root 3 squared plus negative 2 squared. And I have a request for vector problems. So after this problem, I'm going to go to the vector problems. R squared is equal to 4 times 3 plus 4. And then I'm actually going to quickly take this call. Hey, Adam.
Nicholas, what up?
Say hi because I'm live streaming to my Precalc right now.
Oh, hey, Precalc.
Yeah.
Study up.
All right. You're talking about the pool thing, probably.
Now, are you coming to wing night?
I'm probably gonna be live streaming for these kids, so no.
Okay. All right, no worries.
All right. See you, Adam.
All right, see ya.
Bye. All right. Sorry, Adam. That was actually Mr. Golden who showed up in your some of your who taught your trig videos. So by the way, we plug in our points into r squared and we find out r is equal to 4. So that's going to eliminate answer choices B and A. Then we find the inverse tangent of y over x. We see that this is x is positive, y is negative. So that puts us in quadrant 4. So now we have the inverse tangent of y over x is equal to the inverse tangent of negative 2 over 2 root 3. So that's going to be the inverse tangent of negative 1 over root 3, which is going to be equal to 11 pi over 6. So, and that's just from memorizing these unit circles. So the answer choice is going to be 4, 11 pi over 6. Let's say you don't have the unit circle memorized. Then we can just find the inverse tangent of 2 of negative 2 divided by 2 times the square root of 3. And so that's going to be negative 60. And because we're in quadrant 4, we know that you can, the degree value would be, for quadrant 4, 360 minus 60, which is going to be 300. And then in the radians, because the answer choices are in radians, we would find the same value in radians, and that would be negative 1.04. And what you could ultimately do is you just have to know that this is going to be equivalent to pi over 6. And so 2 pi minus pi over 6 is equal to 12 pi over 6 minus pi over 6, which is equal to 11 pi over 6. So that's how you do it if you don't know the unit circle. All right, now we have requests for vector problems. So I'm going to go to vector problems, But here's one thing you guys should know, and that is that vectors, you're probably only going to have one vector problem. Also, word around the street is there's a dot product problem, which we didn't teach because it wasn't the standards. But that just might mean it's a... That just means it's, sorry. Yeah, that just means that it's probably a field question. All right? Vectors. All right. Scalar, so let's start with the quick notes. Scalar will just our magnitude only. A vector is both magnitude and direction. Component form breaks it down into its horizontal and vertical components. Horizontal is the x component, vertical is the y component. To add and subtract vectors, we add and subtract the horizontal components from the vertical components. This can be done using the cosine and sine functions. Scalar multiplication changes the magnitude. And if all vectors are placed tail to tip, then the resultant vector can be found by drawing it from the tip of the first to the tail of the last. Okay, let's start with, all right, vector problems. Let's start with number 1 to start going. A sprinter runs 18 miles per second in a direction of 22 degrees south of west. Which answer choice gives the component form of the vector that represents the sprinter's velocity? So what we first need to do is convert our compass directions to standard angle. Compass directions to our standard angle. So we'll draw it out for this first one. East, north, west, south. And we are 22 degrees south of west. So we start at west, then we move 22 degrees in the south direction. So that's going to be plus 22 degrees in the south direction. So total, if you go all the way from east to west, that's 180 degrees. So that's 180 degrees plus 20 degrees. So theta is equal to 180 degrees plus 22 degrees. So that's going to be equal to, theta is equal to 202 degrees. And now we just have our magnitude. So theta, that's a direction is theta, and our magnitude is 18. So to find the component form, we just need to use our component formula. So our x component is going to be 18 times the cosine of 202 degrees. And our vertical component is going to be 18 times the sine of 202 degrees. So what I'm going to do is grab my calculator and make sure I am in degree mode because we're dealing with degrees here. For the kids. That was for the fans. All right. So we're going to put in 18 cosine of 202 degrees. That's going to be negative 16.69. And we're going to find 18 times the sine of 202, which is going to be negative 6.74. And so our answer is going to be negative 16.69, negative 6.74. Got that in my calculator. And that's going to be answer choice A. a wind is blowing from the northwest towards the southeast can be represented by the vector. The vector has a westward component and a northward component. If the westward component has a magnitude of 13 hours, the northward component has a magnitude of 9 miles per hour, what direction is the wind blowing? So, because this gives us our direct north and west component, this actually gives us our horizontal and vertical component. So, north, east, south, west. If you're going west, that would actually be the negative part of the x-axis. So our horizontal component is going to be westward component has magnitude 13. So it's going to be negative 13. And the north is a positive part of the y-axis. So our y component is going to be positive 9. So from our horizontal and vertical components of the vector, then what we need to do is convert the horizontal components into our magnitude and direction form. So in order to do that, what we're going to do is we're going to have the theta, which is going to be our degrees, is going to be the inverse tangent of y over x. So the inverse tangent of y over x is going to be the inverse tangent of 9 over negative 13. And so that's going to be negative. So our calculator output is going to be negative 34.695, but we're not done yet and we need to think critically, critical thinking. So for 13, if our x component is negative and our y component is positive, that's going to put us in quadrant 3. Because we're going west and north. So that puts us in quadrant 3, which means that this actual value of this angle is going to be right here. So it's going to be 180 minus the actual value of theta is going to be, that's their calculator output. But our actual value is going to be 180 minus 34.695. And if it asks for our actual angle, we could calculate that. But this just says 34.7 degrees north of west. So in fact, by starting at west and going 34.695 towards the north direction, that's actually the same thing as this calculation right here. So with some critical thinking, we can find out that this is the correct value. All right. Wait, so you can't see. Jose says he can't see. Jose, how specifically can you not see? Oh, God. That's why you couldn't see, because I'm being silly. So, this is the work. So, all right, yeah, I'll be better about projecting what's actually going on. There's a little bit of screen buffering and delayed feedback on my end, so I'm sorry for not being accommodated in that aspect. Okay. Now, do we want to continue with vectors? These are vector problems. There's going to have one vector problem, so it's not going to be as heavily tested. So, continue with vectors or more polar? Oh. Okay, so where there's little sequences. All right. All right, so we have our sequences here. Sequences. Get the sequence here, in case I've solved anything. All right. The sequence is a series. Let's do the quick notes first, and then we can do problems. All right. A sequence is a patterned list of numbers. The recursive form can be used to find the next term of the sequence, an plus 1, given the current term, an. The explicit form can be used to find any term of the sequence given the numbered item you want to find n. An arithmetic sequence adds the same number each time. This value is called the common difference. And it's given by the variable d. And the explicit form looks like a linear function. When simplified, distribute and combine like terms. The geometric sequence multiplies the same number each time. The value you multiply from one term to the next is called the common ratio. That's going to be r. The explicit form looks like an exponential function. A series is the summation of a sequence. And the partial sum, Sn, of a series adds a finite number of terms. An infinite series, S, adds every number to the sequence. An infinite series is said to converge if it sums to a finite value. And diverges not. Arithmetic sequences always diverge. Geometric series converge if the absolute value of r is less than 1. Okay. All right, so let's go to problem 1. I believe we've already done this, but there's no harm in doing this more. Evaluate the series. So this one, you're both multiplying. I guess you're multiplying, but because your starting point is n equals 4, it's just easiest to, you can just draw everything out and conceptualize it if you know what the series is. So we notice our starting point is 4 and we finish at 8. So we're only evaluating the sum of when n equals 4, 5, 6, 7, and 8. So we do the 4th term, the 5th term, the 6th term, the 7th term, and the 8th term. All right? So we have 3n minus 2. So it's going to be 3, and we plug in n, times 4 minus 2, 3 times 5 minus 2, 3 times 6 minus 2, 3 times 7 minus 2, 3 times 8 minus 2. So this is going to be equal to 12 minus 2, 15 minus 2, 18 minus 2, 21 minus 2, and 24 minus 2. Using some mental math, this is going to be 10, 13, 18 minus 2 is 16, 21 minus 2 is 19, and 24 minus 2 is 21. And what we can do is we can just do 10 plus 13 plus 16 plus 19 plus 21. It's going to give us, oh, I did 10 plus 13 plus 16. Oh, 24 minus 2 is 22. Sorry. So that's minus 21 plus 22. The answer choice is 80. B. Sorry. So 24 minus 2 is 22, not 21. I was silly for doing that, and I apologize for my silliness. All right. Let's go to number 2. If a convergent geometric series has an infinite sum of 4 and a common ratio of 0.3, what is the first term in the series? So with the geometric series, this is from the formula sheet, but you must apply. This is on your formula sheet, but you must be able to apply. And by the way, because I'm doing this video, it's going to protract my grading until later into the night, but that's okay. S is equal to A1 over 1 minus R. So that means that 4 is equal to A1 over 1 minus 0.3. And this is equal to 4 is equal to A1 over 1 minus 0.3 is 0.7. So what I do is I multiply each side by 0.7. And here the 0.7 cancel out. And I have A1 equals 0.7 times 4. And 0.7 times 4 is 2.8. So A1 is equal to 2.8. So that's the first term of the sequence. And so that's going to be answer choice D, 2.8. All right. Before I move on to the next problem, I want to ask you guys a question. And that is it possible for you guys to go back in time and view previous practice problems in the stream? Because that's an important feature that theoretically this is supposed to do. I don't know if it's actually doing it. Ooh, someone's name is Creepy Counter-Strike Go. That's funny. And then also, you should text your friends. I want more than 5 people watching. I want more people taking advantage of this resource. All right, thank you, Creepy Counter-Strike Go, whoever you are. All right. I guess we'll move on to number 3, and then what's the verdict on you guys being able to go back and look at previous answers? Because that sucks if that's a feature you don't have access to. Six watching. All right, that's one more person. Hello? Okay, was that because if you guys can go back in time, oh, okay, that sucks. All right, well, I guess we'll just keep on going with sequences, and maybe this can post as a YouTube video. You can watch it later. Okay, so all right, I can go through some problems and then I'll reconvene, see if it's ultimately more useful if I just directly post videos to YouTube. So let's go. The formula for a sequence is given by an is equal to 2 times an minus 1 plus 3, while a1 equals 3. What is another formula that represents a sequence? So I've actually done the video solution for this problem, or for a problem very similar to this, in the review packet, but let's do it very quickly anyway. So in this case, a1 equals 3, and a2 is equal to 2 times the previous term, which is 3, plus 3, which is equal to 9. So, that being said, we have f of n is equal to 3 times 2 to the n minus 1. This is the right answer, but let's see why it is. What we can do is, this is when n equals 1 for the first term. This is when n equals 2 the second term. So, anytime we plug in 1 into this equation and we spits out 3, we know that it matches up with the sequence. So this is going to be 3 times 2 to the 1 minus 1, which is going to be equal to 3 times 1, which is equal to 3. So this could be the first term. Here, this is going to be plug in 1 for n. This is going to be 2 minus 3 plus 8 plus 3, which is not equal to 3. So it's clearly eliminated. Here, this is going to be 2 times 1 squared is 1. So 2 times 1 plus 1 is 2, which is equal to 4, which is not equal to 3. So we can eliminate that answer choice. And for D, we have 3 times 1 squared, so it's 3 plus 8 times 1 is 8 plus 1, which is equal to 11, which is not equal to 3. So that leaves us with answer choice A, if we know the sequences. So let's do number 4 now. Actually, before I do number 4, I want to convene with the 5 people watching and say, because you can't go back, would it be easier if you directly requested problems to my Remind and then I uploaded them as fast as possible? Or do you prefer live stream? And I'll also gonna Google right now, why can't people go back with YouTube Live? Alright, so just wait on your responses for what you think will be best. This is your time. Alright. Waiting on your responses for what your preferences are. Okay. Yeah, just let me know. I'll wait till you guys respond. Okay, I said enable DVR, so viewers should be able to go back 4 hours when I'm streaming. Okay, maybe I can adjust this. Help. Right, we need more people. Let's broadcast alert. None. Prefer it live. All right, enable DVR. Okay, it's not letting me do that. Okay. All right, here's what I might do. Okay, I'm going to stop the stream. Enable DVR and then restart it. So we'll be back shortly. Check Remind for your link. Going to stop streaming.